Hey guys, welcome back. This is our last unit to review. I'll try to go through this pretty quick and it's going to look really familiar. So we're going to review the unit 3 and then you're going to take the last practice test, and tomorrow I'll upload the solutions for the practice test, and that's pretty much it. So you'll have the rest of the weekend right before we come back to finish. Again, you can resubmit any of the homework that you didn't get full credit for. So whenever you come back, we're going to take the midterm test. The happy-go-lucky VeggieTales test, which is what we decided we're going to call it because it's far less intimidating. And then after we take the midterm, happy-go-lucky VeggieTales test, we'll probably have about 30 minutes at the end of the class. We're going to pair up and play a golf game where you get to estimate distances and angles, and I'll teach you guys how to use a protractor. So that'll be a fun partner activity that you can do, and it's a good, I suppose, icebreaker because you'll get to meet somebody else in the class. And we'll enjoy that time together, okay? I'm also kind of planning on doing a lot of our in-class constructions and activities, especially for the fifth unit, which will be, in like 2 weeks or so. Doing those activities in class in person kind of give you something fun to look forward to, and I was wanting to do those anyway like that. So, and then you'll do the rest of the assignments and normal stuff outside of the class, kind of like we're doing right now. All right, but that'll just be a few days like that. And then we'll get into doing a lot of lectures in class because I know you guys will benefit from that. So anyway, really excited about having you guys back in the classroom, and let's go ahead and move on. All right, so parallel and perpendicular lines. So let's say we have this line here. Its y-intercept is 0. The slope looks like we're rising 2 and running 3. So we'd have a slope of 2/3. And then the plus b with it, which would be our y-intercept, is just going to be plus 0, so we can just leave it off. Now, if we had another line that was parallel to it, parallel lines have the same slope, right? They rise and run at the same rate. That's why they don't intersect. So this would have to have a slope of 2/3, and then we could set anything for the y-intercept as long as it's not the same, because if it was 0 as well, it's the same line. Those aren't parallel because they're the same line, right? So I'm going to move this one up to the plus 3 right here. You'll notice both of these rise and run at the rate of 2 and 3, or 2/3. So it's going to have the same slope, and they would be parallel to each other. And we can mark that they're parallel to each other by putting a little chevron here or a triangle or something like that. So those two lines are parallel. If we wanted to make one that was perpendicular, we remember perpendicular lines have opposite reciprocal slopes. So the opposite reciprocal of 2/3 is going to be -3/2. So we change the sign and we flip the numerator and denominator. And for the y-intercept, we can keep it, we can really put it at anything. We could even have it at 0, and that would be totally fine because it's going to be a distinct line, right? Even if I put it at 0, or if I put the y-intercept at 3, it's still going to be a unique line to the parallel lines, right? So it really doesn't matter what value you put for b. We're going to put it at -3 just for fun. So y-intercept at -3 here. And we'll notice, since these lines here are parallel, that means that if this is perpendicular to this one, then it has to be perpendicular to the other parallel line as well. So if -3/2 is the opposite reciprocal of that slope, it's going to be the opposite reciprocal of that slope as well. And we can see that by doing -3/2. We do the opposite sign from negative to positive, then we flip the numerator and denominator, giving us 2/3. And sure enough, -3/2 is going to be the opposite reciprocal of both of the 2/3, so it would be perpendicular to both. Now that's also called the perpendicular transversal theorem, which I'll show you really quick here. So the perpendicular transversal theorem says that if two lines are parallel and the third transversal is perpendicular to one of them, so line 3 is perpendicular to this rail here. So the rails of railroad tracks, they have to be parallel. Now they're not necessarily straight, but they are going to be parallel. They have to be the same distance apart from each other at all times, otherwise bad things happen, right? So if it is perpendicular to one of them, then we know the corresponding angle here means that it has to be perpendicular to the other as long as those are parallel lines. So if the lines are parallel, then the transversal is perpendicular to one of the lines, and it has to be perpendicular to the other line as well. All right, another form that we see things here, we want to know if the lines are parallel or perpendicular. Well, they have to be in the slope y is equal to mx plus b format. This one already is because y is solved by itself, so whatever's in front of the x has to be your slope. So that's a slope of 3, so we rise 3 and run 1. Now over here, the 6 is not our slope because the y is not by itself, and we got to move the x to the other side. So first thing I'm going to do is subtract 6x from both sides. That's going to leave me with 2y, and this is not 10x, it's not 10, right? Because these are not like terms, we can't combine them together. So we're simply going to put it as -6 plus 16. So we're just going to move it, put them next to each other. And notice I put the x term in front of the constant just because we're putting it in non-ascending order. Just how we do things. All right, next thing I got to do is get rid of this times 2. So I'm going to divide all the terms by 2. When I do that, I get y is equal to, that's going to be negative 6 divided by 2 is negative 3x, and then negative 3x plus 8. It's going to be the last part. So now that this is in the y is equal to mx plus b format, the negative 3 is my slope. So I have positive 3 and negative 3. Well, are those lines parallel? Do they have the same slope? No, because they have opposite signs. But are they opposite reciprocals? Well, no, not quite, because the opposite reciprocal of 3, that was terrible. Let's try that again. All right, so are they parallel to each other? The opposite reciprocal of 3 is actually going to be negative 1/3. So they're not quite opposite reciprocals. Just because they're the opposite sign, they're not actually reciprocals either. So it's not enough just to be opposite. It has to be the opposite reciprocal. So these are going to be neither parallel nor perpendicular. They just intersect. All right, moving on. Corresponding angles. So corresponding angles are going to be made when we have two parallel lines and a transversal that cuts them. The transversal is going to make 4 angles with one parallel line, and it's going to make the same 4 angles with the other parallel line. And we'll notice that the ones that are in the corresponding location, meaning the same location, are going to be congruent. So as I move this up here, notice the angles don't change as long as those lines stay perpendicular or parallel, and that the angle 1 corresponds with the top left at 5, 7 goes with the 3, or whatever, and the 2 goes with the 6, and the 4 goes with the 8. So those corresponding angles are going to be congruent if the lines are parallel to each other. All right, so the corresponding angles theorem is actually a conditional statement that says that if the lines are parallel, and they are from the markings here, then we know the corresponding angles are congruent. So this top left angle has to be the same as this congruent top left angle, so that would be 112. Now we can use the converse of this statement to prove lines parallel. So the converse, like shoes on the wrong feet, just like what we reviewed 2 days ago, we're going to switch the order. So if the corresponding angles are congruent, and they are here, then we know that the lines have to be parallel. So this line is parallel to that line. Now my next question is, what if these two are not the same? So what if the corresponding angles are not congruent? Well, if that's 110, then it's going to be a little bit less than it was before. Let me change that. Okay, so now it's 110. Okay, now 110 and 112 corresponding angles are not the same. Are these lines parallel anymore? No, they're not going to be parallel. So yeah, now they're no longer parallel because the corresponding angles are not congruent. What if I said they were supplementary? So what if this was, let's see, would be 68? Okay, so the corresponding angles are supplementary. Well, that's even worse, right? So they're still not the same, and it's going to look something along the lines of that, I guess. Yeah, that's about 68 degrees. Okay, so are they parallel? No, clearly not, because the corresponding angles are not congruent, so they're going to intersect at some point. Okay, moving on. Alternate interior angles. If the lines are parallel, the alternate interior angles have to be congruent. Now these are called alternate interior angles because they're on the alternate side of the transversal and the interior of the parallel lines. You guys have been doing really good at drawing those arrows and figuring that stuff out, so I must have taught it really well this year. So they must be congruent, so that would have to be 112. No big deal. And then I can use the converse of the statement again to prove they're parallel if the alternate interior angles are congruent, and they are, so the lines would be parallel. But if they weren't congruent, say this was 114, now they would no longer be parallel. This line would be a little bit off like that, and they would intersect somewhere at that point. All right, same thing with alternate exterior angles. They have to be congruent as well if the lines are parallel, and they are. Okay, then if the alternate exterior angles are congruent, that means the lines have to be parallel. Again, we're doing the same thing. And once again, if this was, I don't know, that makes more sense, then at that point, again, they're no longer going to be parallel because the alternate exterior angles are no longer congruent. Okay, same side interior. Now, all of our angle pairs, linear pairs, corresponding angles, vertical angles, alternate interior, alternate exterior, all of those, all 5 of them, they're all going to be congruent. The only ones that are supplementary are the same side ones, which are same side interior or same side exterior, which is rarely used, mainly same side interior. And the same side interior ones have to be same side supplementary. That's how you remember SSS, same side supplementary. So if the lines are parallel, then the same side interior angles have to be supplementary. So this is same side interior because they're on the same side of the transversal, both the right side, and they're on the interior of the parallel lines. Okay, which means the supplement of 112 would be, I believe, 68. Yes. All right, so they would be supplementary. And we can use the converse, of course, if the same side interior angles are supplementary. Ooh, those are not supplementary. Okay, so that would mean that these lines are not actually going to be parallel because those aren't quite supplementary. But if they are supplementary, if this one was 112, then we could say that the lines would have to be parallel by the converse of same side interior angles theorem. Same thing with same side exterior angles, by the way. Oh, we did that in less than 10 minutes. Awesome. And I got to cut a little bit of that out. So anyway, I will post the solutions to go ahead and do the practice final, and I'll post the solutions for it tomorrow, which will be Friday, and then we're almost done. It's almost the weekend. So if you have any missing work, any incomplete work, please turn that in. I'll grade it this weekend and for full credit. See you guys. Have a good one. Oh, yeah.